Hello, 6th grade scientists. So hopefully you were able to watch the Study Jams video, and this information is going to kind of go over what you learned in the Study Jams video and also relate to the lab that we've been working on. Keep it cool, we'll make it melt. All right, so first of all, a lot of people get heat and temperature mixed up. Again, it's kind of like the same relationship between mass and weight. They're kind of interrelated. So is heat and temperature. So heat is the amount of thermal energy that is in matter, okay? Now the reason people get temperature mixed up is because temperature is the measurement to measure that thermal energy. So this is the way to measure thermal energy. So that's how they're interrelated. So in the video, they talked about 3 different types of heat. They talked about radiation. And we think of radiation, we think of the sun. And so radiation is the transfer of heat through electromagnetic waves which move through space. So that radiation moves through space and then heats things up. So it is a form of heat or a form of thermal energy. So then also we have conduction. Now we talked about conduction as heat transferred from one object to another. So you remember the girl in the video, she touched her computer and she had left that out in the sun. And that energy from the computer, the heat energy from the computer was transferred to her hand and it burnt her hand. And she yelled. And that was from conduction because it transferred from the computer to her hand. So you kind of can, I can relate to that because when I get into my car in the summertime, if I pull my seatbelt over, sometimes the seatbelt is really, really hot and I kind of and let go of the seatbelt. And that's because of conduction, because it's transferring that heat from the seatbelt, from the metal clip of the seatbelt to my hand and it burns. So that's a form of conduction. Now, when you think of conduction, in the video they also talked about conductors and insulators. So conductors are things that allow heat to pass through it. So those things heat up very easily, very quickly. So in the lab that we're doing, we're trying to find things that heat up very easily and very quickly so that that Hershey bar will melt. If you looked at the video that I had for you a few days ago, they talked about using black paper. Well, I know that if I owned a black car, which at one point I did own a black car, anytime I got in the black car, it was extremely hot and I had to roll my windows down because it was just miserable in there because heat is trapped inside or is absorbed by things that are dark colored. So in the summertime, you don't want to wear a black shirt out in the sun because you're going to get too hot. So then there are also insulators, and it is difficult for heat to move through an insulator. So you might think of a cooler. Coolers, on the inside of the cooler, a lot of time they'll have like foil, and foil is a good insulator. Foil keeps things cool. If my daughter is going on a field trip and she wants to take a can of pop or a can of iced tea, then what I'll do is I will wrap that in foil to keep that cold because it keeps the cold in. So that kind of gives you an idea of insulators and conductors and what they do. Also though, on the flip side of that with foil, if you put foil in the sun and you have it like up, so like the video you saw that I showed you, they were taking a pizza box and making it into a solar oven. Now if you use foil on the inside of the solar oven, the radiation heat reflects off of that foil and onto the object, and it causes the object to heat up faster. So it depends on how you use the foil on whether it'll be something that will cause something to stay cool or whether it'll heat something up. Then the last form of heat that we have here is convection. And convection is the transfer of heat through a liquid or gas. So, you know, if you take a glass of water or a mug of water with the containers like you could put coffee into, if you take one of those out into the sun, to begin with, your water is nice and cold. Eventually, you'll notice that there's sweating on the outside of the container because the container itself is cooler than the air around it. So you get that condensation on the outside of the cup. Well, that's when it's starting to transfer energy, and it's starting to heat up or warm up that container, or try to. So eventually, if you let it keep going, then the water that's inside your container, especially if you leave it out for a long period of time, it will become, it'll start getting warmer. And what happens is that warmness from the outside of the cup comes inside of the cup, and it slowly ekes through that cup. So it slowly transfers that warmth. Now also too, if you take just a plain old water bottle out into the sun, and even if you're in the shade and you're just holding it with your hand, the heat from your hand will transfer into that water bottle, and eventually that water bottle will become the same temperature as your hand, or that the coolness will come, it'll be back and forth. Your hand will cool down a little bit, but then what's inside the water bottle will warm up a bit. So it'll transfer that heat from your hand to the water bottle. So that's the transfer of heat through a liquid or gas. That's convection. So these are the three types of heat that we talked about. And, specifically the thermal energy is what we talked about with the keeping the Hershey bar cool or melting it, or if you used an ice cube, whichever. So today what I want you to do is I want you to go through and I want you to start performing that lab. Find a sunny spot to put your Hershey bar or your ice cube in your containers that you created. And remember to check them every 5 minutes. Use a timer. And then upload your lab. And I'd like to see a picture. If you could take a picture with your phone and send me a picture so I can put that in my gallery of work. That would be really great. Make sure that your picture does not have your name on it, or if it does have your name on it, I won't be able to put it in my gallery of work. All right, so I'm hoping that you had fun with this week, and just an interesting way to investigate thermal energy. If you have any questions or concerns, you can always email me. All right, keep watching, keep curious, and always keep learning. I'll see you next week.